Here's your video on Lesson 58, Modeling with Sine and Cosine. I wanted to start off with a couple of definitions, very basic, simple definitions that assume that you know some certain things about what we've been doing already, that you know a few things about how the graphs are made, etc. Now, what is amplitude? Amplitude is how many units up or down we go from the midline. So, for instance, if I had a function, I go up A, and I go down A. The midline is the horizontal line that's halfway between the maximum and the minimum. The period is the distance needed to complete one cycle of a function. One cycle of sine looks like this, and one cycle of cosine looks like this. Frequency is the number of cycles of sine and cosine from 0 to 2 pi. So if you count how many cycles you have, that's the frequency. And there's a very distinct relationship between period and frequency, and that's defined by these two functions. Period is equal to 2 pi over frequency, or frequency is equal to 2 pi over period. We're focusing on creating functions. We're just focusing with a little more detail than we did with the last lesson. So let's do a couple of them. I'm going to move quickly again because these are all a little bit different. So if you feel like I'm moving too fast, you can slow down the playback speed, or you could always jump back and watch the part again that gets you confused. There are a lot of different attributes of these functions that you can be given, so I want to cover a few different scenarios. Create a sine function with a period of 6. Well, remember that we have a sine of w x plus h plus k. Now, which one of these is period? Not this one, not this one, no, not that one, and not that one. Period is going to go into w, but w is frequency. So what we're looking at is we're looking at a function sort of like this. We're looking at a sine of some number x. But I don't know what that number is yet. The period is 6, and I need the frequency. Frequency is equal to 2 pi over period, which is 2 pi over 6, which can get simplified. Divide both those by 2, and I get pi over 3. So my function here is going to be sine of pi over 3 x. Now let's create a sine function with a period of 5, a maximum height of 11, and an average height of 3. So it's sine. I'll start with a little graph. My average height is 3. My maximum height is 11. So that means that my amplitude must be 8, because I can tell the distance between things by subtracting. 11 minus 3 equals 8. So my amp must be 8. They gave me the period, but period does not go into the function. Period is only used to find frequency. So frequency is equal to 2 pi over period, which is 5. And you actually can't simplify this. So that's just it. That's frequency. So my function is going to be y equals amplitude sine of frequency 2 pi over 5 x plus the midline, which is 3. And that would be my final answer. That's my function. Now let's look at question 8. Question 8 is a cosine function with a period of 3 pi, a minimum height of 4, and a maximum height of 9. So let's look at what this function looks like. It's a cosine function. And it looks like that. It has a minimum height of 4 and a maximum height of 9. Now in order to find out the midline, the y equals whatever, I'm going to have to average these two things together. So 9 plus 4 divided by 2 That's 13 divided by 2, which is 6.5. You shouldn't be afraid of the fact that this is decimal. This is a pretty easy decimal as far as decimals go. You shouldn't be afraid of decimals anymore by Algebra 2. What I now need is I need the amplitude. What's this distance in here? Well, I can subtract. So let's say, what's the distance between this and this? 6.5 minus 4 is 2.5. So that's my amplitude. I can check it. If I take 6.5 and I add 2.5, I get 9. If I subtract 2.5, I get 4. Okay, so that works. So I have my midline. I have my amplitude. Now I just need the period. Or rather, I need to convert the period from period to frequency. Frequency is equal to 2 pi divided by p, which means that it's 2 pi divided by 3 pi. And whenever we have something on the top and bottom of a fraction, we can cross it out. So my frequency is 2/3. My final function then is going to be y equals amplitude 2.5 cos of frequency x plus midline, which is 6.5. That would be my final function. There's one more scenario that's a little interesting, and that's question 9. Create a cosine function with a period of 3 pi, a midline of 5, an amplitude of 2, and an initial value of 3. So let's start off with the easy stuff. They gave me the midline. That's awesome. Make that a little straighter. My midline is going to be y equals 5. They say my amplitude is 2. So that means that I go up 2, that's going to be to 7, and I go down 2, that's going to be 3. Now they say that the initial value is 3. Initial means starting. Starting or first are other ways you could say initial value. So my first value has got to be 3, but that's not what a cosine function looks like. A cosine function looks like this. It would start at 7. So what we do is, in order to change this, we flip it. So now it's an upside down U. Flipping upside down requires you to make the amplitude negative. That's it. Make the amplitude negative. So I know that I have my midline of y equals 5. My amp is going to be negative 2. And I just need to figure out the frequency with the period. So change color. So I'll take this 3 pi. Frequency is equal to 2 pi over 3 pi. Pi and pi cross out. And I get that my frequency is 2/3. Now these are all going to go into my function. And my function is going to be y equals negative 2 cosine of 2/3 x plus 5. And just in case you don't believe me about this whole negative cosine thing, this negative amplitude, let's take it to a graph. Now this here is cosine of x. I'll hit zoom, zoom trig. What I'm actually going to do is I'm going to go into the window menu and I'm going to ignore the negatives. So that's what a cosine graph looks like. Let me even change the window a little bit so it doesn't quite go so high. Let's change my y range from -2 to 2 instead. That looks better. So that's our cosine function between 0 and 2 pi, or 0 and 360 degrees. Now if I take that function and I instead draw it as negative cosine of x, it flips the function upside down. Here, look, let me take away the original. It just flipped it upside down. It has the same amplitude. It crosses through at the same places. It has the same zeros. Right? It still crosses through here and here. It still travels from 1 to -1. The heights are still the same. So everything is the same except for its orientation. It's been flipped over, and that allows us to make additional changes to the function. Okay, so if you ever need something to start low, start at its lowest point, that's a negative cosine function. That's all you should need to be able to complete the homework. We'll go over the rest of it in class. Good luck, and I'll see you tomorrow.